Hi, today I'm going to present our work Mitigating Label Biases for In-Context Learning. In-context learning is a popular paradigm for utilizing large language models. However, such in-context learning ability is known to be unstable due to various design choices, such as the choice and order of in-context examples. Prior work shows that such instability of in-context learning rises from that these various design choices introduce biases to the model's predictions. However, there hasn't been any systematic discussion to categorize existing findings on bias problems in in-context learning and to detect a new type of biases and, more importantly, to mitigate the effect of different type of biases. So in this work, we aim to address these problems within the context of text classifications. We start with typology of label biases, and based on which we're able to identify a new important type of bias, which is domain label bias. And finally, we propose the novel calibration method to handle all type of biases. So for any classification task, we consider the following setups, where we have a context that consists of a sequence of labeled examples, we have the text we want to classify, and also we have some label names we want the model to predict. And this can be summarized into the following equations. We see that there are three different components, and we can define three different types of label biases accordingly. So first, we have vanilla label bias, which captures the model's uncontextual preference for label names. And we have the context label bias, which captures the effects from the context. And finally, we conceptualize a new type of bias, which we call domain label bias, that captures the effect of task corpus on the model's predictions. So to confirm that the task corpus can actually bias the model's predictions, we conduct the following experiment. We're given the model some random words and ask the model's preference on each of the label names. We find that on many of the datasets, simply seeing random in-domain words that is sampled from the task corpus can severely bias the model's predictions. But seeing random English words do not show such preference. And on many other tasks, seeing random English words or random in-domain words does not show such a big difference. We found the model performed quite differently on these two different types of tasks. First, on the task with small domain label bias, the in-context learning performs actually quite well. And given some advanced calibration method, the model can even perform better. But on the task with large domain label bias, it's quite a different story. We see that on this task, the language model can barely outperform a chance level baseline, and this is even true with some prior calibration method. To handle domain label bias and the other type of biases, we proposed domain context calibration. It follows prior calibration work to mitigate the effect of all different label biases in a holistic fashion. So specifically, it uses some content-free text to estimate the model's bias on each of the label names, and then use this estimated bias to calibrate the model's original predictions. Prior calibration method uses some single predefined content-free tokens, such as not available as the content-free text, which has been shown to be able to mitigate the effect of vanilla label bias and context label bias. And our domain context calibration, on the other hand, use random in-domain words sampled from the task corpus as the content-free text. This, on the one hand, still is a text that is nearly content-free due to the randomness, but also take into account the domain label bias by using random in-domain words. And to test the effectiveness of our domain context calibration, we conduct the experiments using different models on a wide range of datasets and using different random seeds. So we first observe that domain context calibration improves significantly the average performance of in-context learning on this dataset. And then if we take a closer look by categorizing all of these datasets according to their domain label bias level, we observe a larger improvements of using domain context calibration on this task with larger domain label bias. And if we take a further closer look see the actual predict distribution, we see that after domain context calibration, the model has the better decision boundaries. And all of these findings holds for larger models like GPT-3. So to understand why is domain context calibration better than previous calibration attempts, we conduct comprehensive ablation studies. So first, we observe an improvement by replacing the single predefined tokens like not available to random English words, showing that this predefined token can also be biased. And then, instead of using a single word, using more random words leads to further improvements, showing that it is suboptimal to use only a single content-free tokens. And finally, by using random in-domain words rather than random English words to take into account the domain label bias, we're able to achieve further large improvements. So to summarize, in this work, we propose a systematic investigation of the label bias problems of in-context learning. We start with a typology of label biases, and based on which we're able to identify a new important source of biases in in-context learning. And finally, we propose the calibration method that is able to significantly improve the performance of in-context learning of those large language models. Check our paper for more details, and thank you.